will. Okay? So we're going to see more of this stuff when we put together the remaining orbitals. All right? So 3D gets a little bit more complicated. And we noted because there's 5 ML numbers, there should be 5 3D shapes. You don't have to memorize the names of these as long as you recognize there's 5. And they get rather complicated. So in the positive and negative signs are based on the quadrant that they're in. So again, that's not super important for this discussion. But we can see that those positive signs give us, they alternate, which is kind of to be expected. So those are based, again, on the quadrants that they're located in. Okay? So there's the dxz, the dyz, the dxy, the dx squared minus y squared, and the dz squared is the one oddball here. Okay? And so with 3D, we can calculate the total nodes. N minus 1 equals, so we should see 2 nodes, 2 total nodes for 3D. How many of them are radial? Well, that's N minus 1 minus L. So for 3D, that's going to be 3 minus 1 minus 2 equals, just like the 2P, there's 0 radial nodes with 3D. However, 4D will have some radial nodes, and those radial nodes are internal to the structure. So on my Mathematica calculation here, so the equations get more complicated, the more complicated the orbitals get. And so here is that 3dz squared, and this is pretty cool. I can kind of move it around in this Mathematica calculation. And so here are the other 4 3D orbitals. And I can put them all together, and when you put them all together, it's pretty cool, right? They actually all, each of those lobes, as crazy as it looks, each of those lobes, you know, fit together really nicely, okay? This is also why when atoms get really complicated, when atoms have a lot of electrons, we just approximate them as a sphere, right? Because we notice here there's lobes where each of these electrons could be located. And, you know, for something like iron or titanium or, you know, something that has like 50 plus electrons, it just begins to start to look like a sphere. There's electron, you know, lobes, there's electron density located kind of all over, which gets pretty cool, okay? So now, if I move forward here so we can see some of that when we start to talk about these d orbitals. So I noted that there's 2 nodes for 3D, and those are going to be angular. And you can see those indicated right here, right, by these nodal planes. Okay, so now in the P there was only 1 nodal plane, but in the D there now becomes 2 nodal planes. And now if we look at the probabilities here, we note that 3D, remember 3D has 0 radial nodes, okay? 4S should have 1, 2, 3 radial nodes for 4S. 4P will only have 2, 1, 2. So as you can tell by now, I've been going through these equations for like several lectures now. So you should be really comfortable with doing the math and coming up with these various nodes and what these distributions would look like on our chi-squared versus radius graph, okay? And so the last one I'll describe is the F, and I'm not going to spend a lot of time with this because these get wholly ungodly complicated, and I didn't do these in the Mathematica simulation. But you can see 7 of these things, and here they are, 1, 2, 3, 4, 5, 6, 7, and they get complicated. They get really complicated, okay? And